We're going to talk about the n-squared sorting algorithms. You have selection sort, insertion sort, and bubble sort. So, I guess right to it, selection sort. For selection, the algorithm is going to be choose the smallest element from the list. Choose the smallest element and append to the sorted section of the list. So if we have an array, we're going to have some section sorted and unsorted. We're going to look through every single one of these, pick the smallest element, and put it at the end of this list. So we're going to functionally extend the sorted section one spot further by adding smallest. Note that this is not an online algorithm, meaning that if we added more data while it was running, then we'd actually break the sorts, because let's say this is 0, 2, 6, 8. Here we add a -1. Now when we select this -1 at the middle, we're going to insert it at this spot, which is not going to be in sorted order. Okay? So it's not online. It's not online sort because if we add a new smallest element, it won't be put at the front, in the middle. So, okay? That's selection. Choose the smallest, and that's going to be the next inside the sorted section. Okay, insertion sort. Very, very similar. We're going to let's see, iterate through the array. We're going to iterate through the array and move left as much as needed. What's that? Move left. Okay. So again, we're going to have an array. We're going to have some section that's sorted and some section that's unsorted. We're going to take this element right here, and we're going to move it left as far as possible. So if this element is a 3, and here I have 0, 2, 6, and 8, I'm going to move it to this spot here. So I'm actually going to have to shift this list down. Okay. So what we're going to do is essentially just take the sorted section and extend it one element each time by taking the next element and moving it down as far as possible. Okay. Now, if we add extra elements on the end, this actually does not break the sort. This is an insertion sort is an online sort because if I add -1, now when -1 gets selected, it's less than all of those elements, so it'll actually get pushed all the way up to the front. Okay. All right, so that's how insertion sort works. Bubble sort sort of works almost in the opposite direction. What it's going to do is compare adjacent elements in the array and swap if needed. So, I have my array, and it's going to look at two elements next to each other. If element B is less than element A, so these need to be swapped, we'll go ahead and swap them. Okay? So, look at those. Next, once it compares those and does a swap, now it's going to look at B and C, and see if it needs to do the swap. Okay? So it's going to look at these two, and then this two, so it's going to increment each time. So it's going to look at every single element going down. What's going to happen is large elements are going to go right very, very fast, and small elements are going to slowly bubble up towards the top. If it has to go to the left, it's only going to move one spot at a time each iteration. So if it starts here at the end spot, it's going to take a very long time to get out to the front. Whereas a large element, if a large element is here, it's going to get swapped to B. Now it's larger than C, so now it's going to get swapped to C, and it's going to get swapped all the way down to N. So the first one, your largest element is going to be here. So essentially, technically, you're going to have a sorted list at the end, and an unsorted list here. So that's how bubble sort is going to work. Alright, so those are the n-squared algorithms, and you can easily tell they're n-squared because you have to look at every element to place. You have to look at every other element to place every element. So to place one element, you have to look at n elements.